Hey everyone, we are going to finish up our videos here for this week for lesson number 12. Today we're going to talk about the property of kites. So kites are a type of quadrilateral that is a bit different than what we've seen before. It is not a parallelogram, right? So we don't see opposite sides being parallel to each other. What we do see is, again, a shape like we kind of, it looks like a kite to us. The word kite came before the figure, I would assume. Um, but anyway, it says has two pairs of adjacent equal sides, right? So again, we look here, like in this case, the bottom part, we have two sides that are next to each other. Those are congruent or equal in size to each other. And then we see at the top, that is the case as well. Again, these are not equal lengths, right? So the top lengths do not have to equal the bottom. It's just that we have two pairs, right? So there's four sides total. So we have two pairs that um, are equal to each other, respectively. We see one pair of opposite angles are equal, right? Okay, so this is the tricky one here, right? So we see here in this case that the opposite angles in this particular part, those are equal to each other. Again, the reason we'll know that these are the pair because that diagonal that is there is that diagonal is bisected by the other one, right? So we see how it like, kind of creates two equal sides. So therefore, the angles that they run into are also going to be equal as well. The longer diagonal doesn't have that, right? So the top and bottom of this particular figure don't have equal angles, but we also do know that they are perpendicular, right? So they meet at right angles in the middle. This is important because if we look here at this diagonal, four triangles are made, okay? Of these four triangles, they're all right triangles, right? This is the same thing we see with squares. Um, we're going to see because the diagonals meet at right angles, all of the triangles that are inside that are a result of that are also going to be right angled triangles, which means that everything we know about right triangles comes with it, right? So this is an important fact, and we'll see in a problem we do in just a second or in just a minute that will be the case. Picking the wrong eraser. Okay, so based off of what we learned there, right? So if what are we going to be able to figure out here? How do we figure this out? All right, so this is our first problem. It says quadrilateral PQRS is a kite. What is the measure of angle Q, right? So as always, what are we looking for, right? We're looking for this angle over here. I keep switching my drawing board. I need to just stick with one. I'm going back over here, right? We're going to pick angle Q, okay? So that's the one that we want. We want to know its measure. Well, it doesn't tell us. And we don't know, like with parallelograms, that neighbors are going to be supplementary or anything like that. What we're going to have to do is use what we know. And one of the things we do know is that one pair of the opposite angles are going to be equal to each other, okay? So this set is going to be equal. It's the shorter of the two diagonals. And plus, it has to be because we look at these other angles, they're obviously not equal to each other. So that's a hint. So now we don't know what that number is yet, but we can figure out the total of these two angles because overall, a quadrilateral has 360 degrees. Okay. Right? It has 360 degrees. So if we were to take away the other two angles, it would tell us how much is left. And if we take that number and divide it in half, we get angle Q, right? So that's kind of nice. So if we have 168, quite easily, that is just 168 together, right? So if we perform this subtraction, how much is left over? This is almost 200 degrees. It's going to be 192, okay? Right? So that's not the measure of Q, right? Q and S together make 192. So if we do 192 over 2 is up here, and 192 over 2 is down here, right? That's the measure, right? 192 over 2 is going to be 96 degrees, okay? Right? So again, we know that both of those angles need to be the same. Because of that, when we find how many angles, like how much measurement is missing in the problem, we just divide it in half. Right. So that's one of those properties of a kite. Because they tell us that it is a kite, that has to be true, and therefore we can kind of solve this problem. Okay, so let's look at this other one here, right? So we see a quadrilateral HIJK is a kite, right? So again, they're telling us it's a kite, so therefore all of the properties of a kite kind of follow along. What is GH? Okay, what is GH here? Okay, so this is going to be like our, a little bit different than our other problem, right? So we actually see this, and we have KH here, and we have KG. Okay, and it's asking us for GH. So we want this side here. We don't know it. Now, if we look in this figure, these three sides together form a triangle. Now, that wouldn't be that useful if it wasn't for the one of the properties of a kite. And one of those properties is going to be that it's going to have right angles where the diagonals meet, right? So right around where G is, they're all right angles. So we know that this is a right angle. Now, you may say, well, Joel, what does that mean? I don't know what that means. Or you may say, Miss Corbeil, she's your teacher, right? What does it mean? Well, right angles, and we've learned this before, and in a triangle mean that one property called the Pythagorean theorem can follow along with it. Okay, and the Pythagorean theorem is a theorem that says a squared plus b squared is equal to c squared. Okay, a squared plus b squared equals c squared. So the two sides of a right triangle here and here are a and b, right? That squared together, they have to make the other side c, right? So this is the problem that we're going to do. Quite simply, what we're going to try and figure out is this missing side. I'm going to do this in a, I need to erase some stuff. Ah, I always do this. Right, so in order to solve for this missing side, okay, what we're going to do is we are going to take c squared, which is 52 squared. And we are going to, on the other side, we're going to do 48 squared. And this equation will help us solve for our missing side, GH, right? So it's a little trickier here. Now, what I recommend, if possible, is to use a graphing calculator or use Desmos to do it. I am going to use my calculator here. Now, the way that this is going to work is that b squared is actually going to equal 52 squared minus 48 squared. Okay, 52 squared minus 48 squared. So I'm going to watch this. So I'm going to do 58 squared minus 48 squared. Okay, so you type that in. And you could do this on Desmos as well. This gives me 400. Okay, now, does that make sense that this bottom side would be 400? It doesn't, right? That would be way too big, right? It doesn't look like it's the size of 400. Not that the looks always have to be what it is, but it's a way to check. If b squared is 400, though, right? That's not what b is, right? B is going to be the square root of that, right? So the number that's squared that makes 400 is the square root of 400. Sorry, my computer's lagging a little. This is 20. That's a much more reasonable number here. Okay, it's much more reasonable. So again, that's one of the properties of a kite, is that because it, like a square, breaks all the parts into right triangles, we can bring what we know about right triangles into the fold. One of those things is the Pythagorean theorem. It only works in right triangles, and it tells us that the two legs where the right angle meet, if we square the legs and add them together, that should make the square of the hypotenuse, which is the longest side. Again, a squared plus b squared equals c squared is that problem here.